a video on physics, and I thought motion was a very good topic to choose. Well, if you look through your textbooks, and you will see a lot of kinds of motion like translatory motion, rectilinear motion, curvilinear motion, rotatory motion, vibratory motion, and not to forget loose motions. Well, first of all, we need to define what is motion. Well, the definition is that an object is said to be in motion if it changes its position with respect to time. Like if we have a ball here and it's placed on a table. I know my drawing is not good. After 2 seconds, we see the ball from here to here. Wow! It has changed its position with respect to its surroundings. So the ball is in motion. Now, what is rest? Simply the opposite of motion. Now I'm not going to talk about different kinds of motions, but this video is mainly about simple pendulum. Uh, what is a simple pendulum? Well, let me drag it down. A simple pendulum consists of a rod, a thread, and a ball. Well, this ball could be made of clay or any metal ball. It's okay. You might be thinking, what is in this simple pendulum? It's just a thread and a ball. Well, this has so many wonders that has made scientists. Now, I would be telling some basic definitions of a pendulum. Now, if I hold the pendulum and drag it to here, this would be called as its extreme position. When I release it, it will go from here and then to here and then back to here. Well, let's do some labeling. This is O, this is O, this is A, and this is B. Now the first term we define is amplitude. The distance from O to A or O to B, which is equal, is known as its amplitude. The position O when the thread makes a right angle with the rod is known as its mean position. Now the second term which we define is...
Wait, Gursimul, I mean, mean. Do you mean the English mean or the physics mean?
Oh, well, it's obviously the physics mean.
Which means the center position.
Now the second term we define is oscillation. Okay, when I hold the bob from here, then it goes from A to O, O to B, B to O, and O to A, or O to B, B to O, O to A, and A to O. This is known as one oscillation.
Wait, could it even be to B from B to O to A to O to B?
Oh yes, of course, its path is symmetrical.
Ah, nice. I never thought
Well,
about
there's one more fact which I forgot to tell, that this angle and this angle are equal.
which we will be proving in another video.
Yes, the third part. Now, now the third definition is time period. It's simply the time it takes for the pendulum to complete one oscillation is known as its time period. And now the fourth definition, frequency, is now frequency is the number of complete oscillations taken by the bob in 1 second, and it is denoted by V or F. As everything has a unit, so does frequency has, and you might be wondering about the unit, and that is hertz. Well, there's a fantastic relationship between the time period and the frequency of a pendulum, which I would be telling you, and that is the time period is equal to 1 divided by its frequency. Now let me give you an example. Suppose the frequency of a pendulum is 2 oscillations per second. We can easily calculate the time period by the formula 1 over 2 seconds, that is 0.5 seconds.
Oh, wait. There were some wonders. I thought you said about some wonders in the beginning of the video.
Oh yes, I would be telling about the wonders of the pendulum. So, the wonders of the pendulum are another pendulum. Now here I'm going to connect it. Now, there are some wonders about this, and they are as follows. Now, the time period of this pendulum depends only on one thing, that is the length of the string. Oh, sorry. The more the length of the string, the more the time period it takes, or we can say that the time period is directly proportional to its length. Uh,
Wait. What about the mass? The mass of the bob should depend upon the thing, right?
Wait, Mr. Hunt, you are wrong.
Excuse me, I'm not Miss. I'm Mister.
Okay.
Wait, that means the mass of the bob doesn't depend on
Not
on
at
the
all.
time. And what about the amplitude of the pendulum?
Neither depends on that.
Oh, that's great.
So, there's a simple formula to derive the time period when the length is given. That is, time period is equal to 2 pi multiplied by square root of length divided by g, where g is acceleration due to gravity. Acceleration due to gravity. And pi is universal constant, which is approximately equal to 3.14 or 22 by 7. I was bit wrong at this step. It should be the time period is directly proportional to the square root of the length. So if we make the length 4 times, the time period will become 2 times more. So we conclude that the time period of the pendulum depends only on the length and not on the mass or amplitude. Thank you for watching.